Okay, let's unpack this. I want you to picture a device that sits in, well, almost every office in the world. It has a hard drive, an operating system, a direct line to your internal network, and it handles your most sensitive data payroll, legal contracts, medical records.
Hmm.
And yet, we usually treat it with the same level of respect we give a toaster.
Or a stapler.
Exactly. I am, of course, talking about the printer. But here's the thing, and this is why I am genuinely excited for today's deep dive. Looking at the source material we have from the CompTIA plus Core 1 and Core 2 training modules, that toaster mindset is not just wrong. It's dangerous.
It really is. I mean, if you view a modern enterprise printer as just a mechanical box that spits out paper, you're missing the fact that it's a complex, intelligent node on your network. And because it's often overlooked, it's frequently the largest security hole in the building.
That is the hook that got me. We're going to move past simply hitting print today. We're going to look at the mechanics, the logic, and the care required to keep these machines running. We're going to deconstruct the physics, the software architecture, and yes, we are finally going to answer the question, does shaking the toner cartridge actually do anything? Or is it just something we do out of frustration?
I love that question.
Yes.
And spoiler alert, it is actually a legitimate technical procedure, but we'll get to the physics of that in a bit.
I can't wait.
Yeah.
So let's start at the very beginning. The physical setup. You're setting up a new workspace. The sources list the standard selection criteria. Speed, resolution, paper handling. That's the spec sheet stuff.
Right. Speed is ppm pages per minute. Resolution is DPI dots per inch. If you're a graphic design firm, you prioritize DPI for those crisp vectors. If you're a law firm printing 500-page briefs, you don't care about the dots. You care about the ppm. You need speed.
But where it gets interesting and where the sources get surprisingly specific is the unboxing phase, the tape hunt.
Oh, the tape hunt. This is a rite of passage for any IT technician. Manufacturers tape down everything to prevent moving parts from shifting during shipping, and I mean everything. The source material emphasizes removing all packing strips, especially the ones inside the machine.
Why is that such a critical point in a technical manual?
Because of torque. Enterprise printers have powerful motors. If you miss a piece of tape that's securing a roller or the transfer belt and you turn that machine on, the motor is going to try to spin. The tape holds fast, the motor pushes, and snap. You strip a plastic gear or burn out a clutch immediately.
Wow.
You can destroy a $5,000 machine in 3 seconds just by missing one orange strip of tape.
That is a high-stakes unboxing. And there was another environmental factor I hadn't considered, acclimation. The source is warned against plugging a printer in immediately after it arrives.
Yeah, this is pure physics. Think about a laser printer. It relies on precision optics mirrors, lenses, and high heat. If that printer has been sitting in a delivery truck in February, the chassis is freezing. You bring it into a warm, humid office, and what happens?
Condensation.
Yeah.
Like my glasses fogging up.
Exactly. Moisture forms on the mirrors, the lenses, and even the circuit boards. If you power it up while the optics are fogged, you get blank pages or laser errors. Worse, if there's moisture on the high-voltage power supply, you could short the board.
Oh.
The recommendation is to let it sit for a few hours to reach room temperature. It's not just being polite to the machine, it's protecting the electronics.
That is a pro tip I would have never considered. So we've unboxed it, we found all the tape, and it's acclimated. Now we connect it. The sources list the classic options,
Yeah.
USB and Ethernet.
Right. USB is the direct connection, standard Type B on the printer side, that's the square one, and Type A on the PC. Although the sources note that technicians really need to carry USB-C adapters now because modern laptops are dropping the old ports entirely.
But USB is mostly for a single person, right? Like on my desk at home. In an office, we're talking about Ethernet.
Ethernet is the office standard. It uses the RJ45 port. This connects the printer directly to the network, giving it its own IP address. It becomes a standalone device that anyone in the building can access. It's stable, it's fast. But then we have wireless, and this is where it gets really interesting because there are 2 distinct modes that people confuse.
Infrastructure mode and Wi-Fi direct.
Correct.
Yeah.
Infrastructure mode is what you're used to. The printer connects to your Wi-Fi router, just like your laptop does. They talk through the router.
So it's part of the managed network.
Exactly. And Wi-Fi Direct. It turns the printer itself into a hotspot. It broadcasts its own signal. A device, say, a guest's smartphone, can connect directly to the printer, bypassing the corporate router entirely.
That sounds convenient, but also risky.
It creates a bridge. I mean, if that printer is plugged into your secure wired network via Ethernet, but also has Wi-Fi Direct turned on, you've potentially created a backdoor that bypasses your firewall. A knowledgeable attacker could connect to the printer wirelessly and then hop onto the wired network. The sources are very clear. Use Wi-Fi Direct with extreme caution in an enterprise environment.
Okay, physically we are set up. But a printer is just a paperweight without the software to tell what to do. Let's talk about the brains of the operation, drivers.
The driver is the translator. Your operating system speaks Windows, your printer speaks hardware. The driver takes the document from your OS and translates it into a language the printer understands.
And usually this is automatic, plug and play.
Usually. But the CompTIA material highlights a specific manual method that every technician needs to know. The Have Disk button.
Have disk. That sounds like something from the 90s.
It is a legacy term, but the function is vital today. See, when you plug in a printer, Windows might try to install a generic driver, or worse, the manufacturer's installer tries to load 500 megabytes of Solution Center bloatware that pops up every time you boot your computer.
I hate that stuff.
Exactly. As a tech, you want control. You download the specific bare-bones driver file. Then in the Add Printer Wizard, you click Have Disk and browse to that file. It forces Windows to use the exact driver you want without the fluff. It's the cleanest way to install a printer.
And once the driver translates the data, it uses a page description language, or PDL.
Right. PDLs are the code that defines the page layout. The big ones are PCL, that's Printer Command Language, and PostScript.
Is there a practical difference for the user?
PCL is generally faster for standard Office text. It relies on the printer's internal processing power. PostScript is the industry standard for high-end graphics. It treats everything as mathematical vectors. If you're printing architectural blueprints or marketing proofs where the color and scale must be exact, you want a PostScript driver.
Now, there's one distinction in the configuration settings that always trips people up, and the sources make a big deal about it. The difference between printer properties and printing preferences. They sound like the same thing.
They do, but they serve two different masters. Printer properties is for the administrator. This is where you manage the hardware updating drivers, changing the IP port, setting security permissions. If you change something here, you change it for everyone who uses that printer.
Okay, so that's the global setting. And preferences.
Printing preferences is for the user. This is where you set job-specific defaults. Do you want landscape or portrait? Do you want double-sided? Do you want to pull paper from tray 2? If I change my preferences, it doesn't mess up your settings.
That is a crucial mental model. Properties is the machine, preferences the job. Speaking of the machine, let's pivot to what I think is the most alarming part of the source material. Segment 3, the hidden danger. The source cites a report saying 61% of large enterprises have suffered data breaches related to insecure printing.
61%. It's a staggering number, but it makes sense when you think about it.
Why? I mean, who is hacking a printer?
Well, think about what a printer is. It's a computer. It has an operating system, a hard drive, and network access. But often, IT admins lock down the servers and the laptops, but they leave the printer with the default password.
Admin?
Exactly, or 1234. If a hacker gets into your network, they scan for these devices. Once they have admin access to the printer, they can intercept jobs on the network, see what's being printed, or use the printer as a pivot point to launch attacks on other secure servers. It's often the weakest link.
And the sources mentioned something about hard disk theft.
Yes. Enterprise printers spool documents to an internal hard drive before printing. That drive retains data. If you print a confidential payroll spreadsheet, a copy lives on that drive. Now imagine you upgrade your office printers, you sell the old ones to a refurbisher. Did you wipe the drive?
Most people wouldn't even think to do that. They'd wipe their laptop, sure.
Precisely. If you don't secure wipe that drive, the person buying it potentially gets a digital copy of every sensitive document you've scanned or printed in the last 2 years.
That is terrifying. So what are the fixes? What do the sources recommend for hardening the printer?
First, user authentication. You shouldn't be able to just hit print and have paper fly out. You should have to authenticate. This leads to secured print release.
This stops the sprint and pray method, right?
It's print pray.
You know, where you hit print on a sensitive document and sprint down the hallway hoping to grab it before anyone else sees it.
Yes, exactly. Secured print eliminates that. You send the job, but the printer holds it in the queue. It doesn't print a single page until you walk up to the machine and enter a PIN or swipe your employee badge. The document only exists physically when you are standing there to receive it.
That seems like it should be mandatory.
It absolutely should be. And on the back end, you need to change those default passwords. You need to update the firmware. Firmware updates often contain security patches for known exploits. And disable unused protocols. If you aren't using FTP or Telnet to manage the printer, turn them off. Close those doors.
Okay, so we've bought it, connected it, and secured it. Now we have to keep it alive. This is the care and feeding segment. The sources break this down by printer type, and the mechanics here are wildly different. Let's start with the big one, laser printers.
The workhorse. Laser printing is a fascinating, complex chemical process. The sources list 7 specific steps.
Let's rattle them off because the order matters for troubleshooting.
It does. The steps are processing, charging, exposing.
Okay, processing, charging, exposing,
Developing.
transferring, fusing, and then finally, cleaning.
It sounds like a photography darkroom.
It's very similar principles. Processing is the memory work. Charging puts a high-voltage negative charge on the drum. Exposing is where the laser writes the image, removing the charge. Developing is where the toner jumps onto those exposed areas. But here is where we get to the shake.
Yes, the toner shake. Tell me why this works. So toner isn't a liquid. It's a very fine plastic powder. But it behaves like a fluid when it's aerated. Over time, it can settle and pack down in the cartridge. When the sensor says low toner, it often just means the sensor can't see the toner because it's clumped in the back.
Oh.
Taking the cartridge out and gently rocking it side to side aerates the powder, fluidizes it, and redistributes it evenly.
So it's not just magic, it's fluid dynamics.
It is, and you can often get another few hundred pages out of a dead cartridge just by waking up the powder.
But when it is actually empty, the sources are very clear on disposal.
Never throw it in the trash. Toner is hazardous waste. It's messy, it's bad for the environment, and in large quantities, the dust is actually flammable. You must use recycling programs.
Now, what about the maintenance kit? This isn't just toner.
No. Laser printers have high-wear parts. The fusing step we mentioned, that uses heat and pressure to melt the toner into the paper. That fuser assembly wears out. The pickup rollers that grab the paper are made of rubber. They wear smooth. A maintenance kit is a box of these specific parts meant to be replaced every 100,000 to 200,000 pages. It's like doing a timing belt on a car. You do it preventatively so the machine doesn't fail.
Okay, let's switch to inkjet. These are the ones usually found in homes or smaller offices.
Right. And the tech is different. You have 2 main methods, thermal and piezoelectric.
What's the difference?
Thermal, used by brands like HP and Canon, literally heats the ink. It boils it until a vapor bubble forms, and that expansion forces a droplet out of the nozzle. It happens in microseconds.
That sounds incredibly violent for a quiet machine.
It is. Piezoelectric, used by Epson, is different. It uses a crystal that vibrates when electricity hits it. The vibration pushes the ink out. Because it doesn't use heat, you can use a wider variety of inks, like dye sublimation, without changing their chemistry.
But regardless of the method, the maintenance rule here seems to be use it or lose it.
That is the golden rule of inkjets. Liquid ink contains solvents. If you let an inkjet sit for 3 months without printing, the solvent evaporates and the ink turns into a solid plug in the nozzle.
Right.
You have to run it regularly. If you do get clogs, there are utility programs to run head cleaning cycles, which force fresh ink through to clear the blockage.
Moving on to thermal printers. These are the receipt printers, right?
Mostly, yes.
Yeah.
Or shipping label printers. They don't use ink or toner. The paper itself is chemically treated to turn black when heated.
Which means the paper has a wrong side.
It does. It has a shiny, heat-sensitive side. If you load the roll backward, the print head heats the back of the paper, and you get blank receipts coming out. And because it uses heat to print, the enemy of thermal prints is, well, heat and sun.
Oh, yeah.
If you leave a thermal receipt on your car dashboard, it will turn completely black or fade to white.
And for cleaning, the sources had a specific warning here.
This is critical. The print head is very delicate. Sometimes label glue gets stuck on it. People try to scrape it off with a knife or a screwdriver.
I could see that happening.
If you scratch the heating element, the printer is garbage. You get a white line through every barcode. You must use a specific cleaning pen. It's basically an alcohol marker or an alcohol swab to gently dissolve the residue.
Got it. No knives on the thermal printer. Last type, impact printers. Dot matrix. Why are we even talking about these? Are we trapped in the 80s?
You'd think so, but try walking into a car rental agency or a warehouse. They are everywhere. They have one superpower that lasers and inkjets don't have: impact.
Why does that matter?
Multi-part forms. Carbon copies. If you are a mechanic shop and you need a form where you sign the top and it copies through to 3 colored layers underneath, you need impact. A laser printer just lays toner on the top sheet. It doesn't press through. As long as we have carbon copy forms, we will have dot matrix printers.
That makes perfect sense. And for Hayton's?
It uses a ribbon, like a typewriter. Ribbons don't run out suddenly. They just get lighter and lighter. You replace them when the print is too faint. And you have to watch the tractor feed, those little wheels with the pins that grab the holes on the side of the paper. Aligning those is an art form. If they're too tight, the paper rips. Too loose, it jams.
Okay, so we've covered the types. Let's talk about some specific features and troubleshooting logic. Duplexing.
Printing on both sides. It saves paper. The mechanism is cool. You'll see the page come out halfway, pause, and then get sucked back in. That's the rollers flipping it over to print the second side.
And scanners. We aren't just printing, we are capturing.
Right. The big term here is OCR optical character recognition. That's the software that turns a picture of a document into searchable text. But for the admin, the headache is usually the destination.
Scan to email versus scan to SMB.
Exactly. Scan to SMB means sending the file to a shared folder on a server. It's great, but it requires authentication. The scanner needs a username and password to write to that folder. If you change your network password and forget to update the scanner's configuration, suddenly nobody in the office can scan. It breaks immediately.
So when things go wrong, and they will, what is the troubleshooting logic? The sources give us a hierarchy.
Always start with the physical. It sounds stupid, but is it plugged in? Are the cables secure? Is there paper in the tray? Then move to the OS. Does Device Manager see the printer?
What about the print spooler? That term comes up constantly in troubleshooting.
The spooler is the Windows service that manages the print queue. If you hit print and nothing happens, or if a job gets stuck saying deleting forever, the spooler service is usually crashed. The fix isn't to reinstall a printer, it's to go into Windows services, restart the print spooler, and clear the temporary files. It's the turn it off and on again for the printing system.
And finally, paper jams, the bane of our existence.
Two things here. First, verify the paper size settings. If the computer thinks it's sending legal size, which is 14 inches, but the tray has letter size 11 inches, the printer expects the paper to take longer to pass through the sensors. When the paper exits too fast because it's shorter, the printer assumes something is wrong and jams.
So a configuration error can look like a physical jam.
Exactly. And second, if it jams repeatedly in the same spot, clean the rollers. If the rubber pickup rollers are dusty, they slip. They can't grab the paper, or they grab it crooked, and you get a crinkle jam. A little water or rubber cleaner on those rollers fixes 90% of feed issues.
Clean the rollers. It's such simple advice, but I bet nobody does it until they call IT.
Almost nobody does.
So we've covered everything from the tape hunt during unboxing to the high-stakes world of printer security and the specific care needed for laser versus thermal units. It turns out these machines are a lot more than just plastic boxes.
They are the intersection of mechanics, chemistry, and networking. They're complex.
And here's a thought I want to leave everyone with. We talked about the hard drive security. Think about your office copier. Maybe you're upgrading next week. That old machine is going to be sold or recycled. If you sold your laptop, you'd wipe the drive.
Right. Immediately.
But are you going to wipe the printer? If you don't, does the person buying it on the secondary market now have a digital copy of every contract, every tax form, and every confidential memo you scanned in the last 5 years?
That is a question that should keep every IT manager awake at night. If you don't know the answer, you need to go find out today.
Exactly. Look at your office printer with a new level of respect and maybe a healthy dose of suspicion. Thanks for listening to this deep dive. We'll catch you on the next one.